Hi, everyone. My name is Jessica Skaggs, and I'm a consulting software engineer at LexisNexis Risk Solutions Group. Today, I'm going to talk about how I've used ECL Workunit Services standard library functions and SOAP calls to the ESP web service to capture details about work units running on Thor and use that information to create a report in Power BI called HPCC Thor Monitor. HPCC Thor Monitor allows for slicing and visualizing the data collected from Thor to gain insights into how the system is being used and to investigate problems. Here's a quick overview of the topics I'm going to cover. First, I'll talk about how to collect work unit data using Workunit Services standard library functions and SOAP calls to the ESP web service. This is the data that's used as the backend to the HPCC Thor Monitor. Next, I'll talk briefly about the system flow and how the data gets to Power BI. And finally, I'll demo HPCC Thor Monitor in Power BI so you can see how the collected information can be used. So let's take a look at a few Workunit Services standard library functions that we use to collect the data for HPCC Thor Monitor. The first one we're going to look at is Workunit List. Workunit List returns a list of Workunit IDs with details including things like the state, cluster, owner, and job name. You can set parameters to collect the list of Workunit IDs based on various attributes. For example, you could pass a username and get only the Workunit IDs for that user. You can also specify if it should return Workunit IDs that have been archived. What I do is use the low Workunit ID and high Workunit ID parameters to capture a list of non-archived work units that have run within the date and time range. So I'm passing the Workunit ID with the start date as the low Workunit ID, and then a Workunit ID with the end date as the high Workunit ID. And here's an example of how I do that and the output from Workunit List. And you can see all the things that are being returned for each work unit. So once you have a list of Workunit IDs that you're interested in, you can then use other functions to get details about those work units. Each of the functions accept a Workunit ID as a parameter and then return details about that specific Workunit ID. The first one we're going to look at is Workunit timings. This one will return the time spent in each step. In yellow, you'll see an example of how this function reports the graph timings. I parse this to collect the duration for each graph and subgraph. I've noticed that if the work unit runs on HTHOR, then the name value looks a little different, so the code has two regular expressions to cover both options. I also collect the compile time, which you'll see here in purple, the processing time, which you can see here in pink, and the DFU time, which is a sum of entries with DFU activity like spray, despray, or copy in the name, which is shown here in teal. And as you can see, the DFU row also has the DFU work unit ID in the name. So we can parse that out and we can keep track of which DFU work units were created by this job work unit. And this will come in handy later when we collect all of the DFU work units from the system and we want to tie back to the job work units that created them. The next one we're going to look at is the work unit timestamps. The work unit timestamps function returns timestamps for each of the steps in the given work unit. I use this to capture the start and end time. The start time will show up as an ID of created with an empty application value, which you can see here in yellow. And the end time will show up as an ID of finished and an empty application value, which you can see here in purple. Note that if the work unit has restarted or it runs regularly via cron, it will actually have multiple started and finished times. So you'll need to decide how you want to treat that scenario and which time you want to count as your end time. Another one we can look at is work unit messages. Work unit messages returns all of the messages associated with a work unit. And this includes informational messages, warnings, and errors. The errors will have a severity of 2. Note that a work unit may have more than one message associated with it. And in this example, we can see there are 2 messages for this work unit, and one of them is a sev2 error. So now that we've looked at the different functions, let's see how we can use them. This is a simple example of how I'm using the Workunit Services functions. In this example, I'm capturing the error messages for all work units run between 9.8 and 9.9. So first, I capture a list of work units in the date range using the Workunit List function. Then I project that list and call the other Workunit Services functions within the transform to create child data sets with the timings, timestamp, and messages details for each work unit. If you're not running on HThor, you must wrap the Workunit Services call in no Thor because it cannot run from a Thor slave. So the GetWorkunitList function returns a data set with each non-archived work unit on the system from 9.8 to 9.9 with a child data set with the timings, a child data set with the timestamps, and a child data set with the messages for that work unit. Next, in the GetErrorMessages function on the right hand of the screen, I normalize the messages from the WorkunitMessages child data set, skipping over the messages that are not errors. So what this gives me is this output here, where you can see a data set with all of the work units run between 9.8 and 9.9 with their error messages. I do something similar to capture the other work unit details. I normalize the timing and timestamp information out of the child data sets for each work unit and transform the data to capture the information I need. For example, summing up all of the graph timing entries in the timings data set to come up with the Thor time for the job. So in addition to the Workunit Services standard library functions, I make SOAP calls to the FileSpray ESP web service to collect information about DFU work units. The DFU work units are created for operations such as spraying, despraying, and copying. And this is useful information to capture if I want to track how much data is being moved around. So the first thing we're going to look at is the GetDFUProgress SOAP call. This returns all of the DFU work unit IDs from the system that have not been archived. And you can see the URL for this FileSpray web service in the red box. The IP is the IP of the ESP server. So on the right-hand side, you can see an example of calling this SOAP call and normalizing the results to get a data set and all of the DFU work unit IDs, which is shown on the right-hand side. I use this to get a list of DFU work units similar to the way that I use WorkunitList to get a list of job work unit IDs. So now that I have a list of all the DFU work units from the system, I want to get some more details about them. To do that, there are two more SOAP calls that I use. So the first is GetDFUWorkUnit. This call returns details about the DFU work units passed in, including the job name, the user, the source and destination, and the start and end time. It also returns the command field, and the command field is an integer that can be mapped to the type of DFU action. So for example, 7 is despray and 6 is spray. The next one we'll look at is the GetDFUProgress. In this one, it returns the progress details such as the time taken and the state of the DFU work unit. And it also returns this progress message that can be parsed to get the size of the data that was moved around. So here you'll see that I take the DFU list that I got from the first SOAP call, I pass it into this SOAP call, and I get returned a data set that has each of the work unit IDs along with all of the progress details. So now that I've shown you how I'm collecting the data about the work units, I want to show you how that data gets to Power BI. We're collecting data from multiple Thor environments, so the ECL code that uses the Workunit Services functions and the SOAP calls runs on each Thor environment to collect the data, and it outputs 4 data sets. One with the list of work unit IDs and the details from work unit list and work unit timings. One with the graph timings for all of the work units with 1 record for each subgraph. One with the error messages and all of the work units with 1 record for each error message. And then finally, one with a list of DFU work unit IDs and the details that we collected from the SOAP calls. Next, there's ECL code that collects the data from each Thor environment, combines it with the data from the other environments, does some minor transformations, and then joins it with the historical data. And after that, there's ECL to despray the data to a Windows server where it's picked up and loaded to a SQL Server database. Power BI is connected to the SQL Server database to pick up the data. So now that you understand how to collect the work unit data, let's take a look at the HPCC Thor monitor so you can see what kinds of visualizations you can create from this data. So here is HPCC Thor monitor. There are several pages to the report. I won't be covering all of them, but I'll show you a few to give you an idea of how we're using the data that we captured. The first page we're looking at is the summary page. This is intended to give an overview, and most of this information is available in more detail on other pages. On each page, you'll see drop-downs on the left and across the top that allow you to filter to what you're interested in. We collect data from multiple Thor environments, so you can select which one you want to look at from the environment filter. You can also filter on other details like what the cluster is, what state they're in, who the owner is, what ECL version was on the system when the work unit ran, and the specific job names. The tool defaults to showing work units from the last week. You can expand to a longer date if you want to see more history, or you can reduce the date range to just the last day or two. So for example, I can change the date range to filter to the last month, and the page will update and change to show me all of the details for the last month instead of the last week. So some information on this summary page that you can see. You can see how busy Thor is at different hours of the day. You can see some statistics in the last time the data was collected from Thor. You can see work units that ran longer than what is typical for other jobs with the same name. You can see counts of failed and aborted work units by day. And you can also see recent failures and jobs with the most errors on the bottom. The next page we're going to take a look at is the time by date page. On this page, the top chart is showing the total time in seconds by day. The coloring represents the state of the work units the last time the data was collected. So completed is green, red is failed. And the bottom chart shows the compile time, Thor time, process time, and DFU time by day. If you'll remember, this is the information we collected using the work unit timings function. So I haven't filtered by a specific job or any other attribute. So we're currently looking at the sum of all the time spent on all work units on this environment over the last week, day by day. So we can use this page to see activity on Thor as a whole, or we could filter on a specific job and get detailed information about that job over time. And both of these charts start out at a day level, but they can be viewed at a year, month, day, or individual work unit level. So I'm going to show you that. If I change the date range to the last 6 months instead of the last week. So now I'm looking at day by day over the last 6 months. I can come up on the left-hand side of the chart and do a drill up. I could do that on both of these. So now what we're looking at is the total time month to month. So you can compare month to month on the whole system, how much time was spent processing work units. And it looks pretty even. March had a slightly more. The other thing we can do is go down to a work unit level. So if I change this back to 1 week, and now I'm going to filter on a specific job. Well, maybe I'm going to filter on a tier instead. So let's filter on tier 1. So tier 1 jobs are just a list of jobs that are high priority, that we've specified as high priority. So we'll go ahead and now we're still at the month level. So I can drill down back to the day level. And if I drill down one more, I'll be at the individual work unit level. And if I hover over these, I can see what specific work unit each of these were, and I can see which one took longer. And if I am filtering on a specific job, I can see exactly how long those jobs took compared to others. So this whole page is showing us at the sum of the times, which is useful if you want to compare total time spent processing from one period to another. You can also choose this show average times button, and this will show you the average times instead. So this is useful if you want to see how a job is performing over time without it being skewed by the number of work units that ran in that period. So the next page we want to take a look at is the errors page. So this page shows you all of the work units that have had an error in the last week and their error messages. Remember that we collected the error messages using the work unit messages function. So we can see that there have been 300 work units with error over the last week, out of 11,436. So that gives us a 2.62% error rate. The bar chart is showing us the error rate by day. And we can see that for some reason on the 12th, there was a 12.72% error rate. So obviously something was going on that day. So we can select that day and it will filter the whole page to show me just that day. And then you can take a look at the error messages that happened. There was an email issue that day. So a lot of things failed because of an email issue. On the top chart, you can see all of the job names that have had at least one work unit with an error. It lists the total number of work units and the total number of errors, and then the error rate for that specific job name. So for example, this ASR work unit job, there have been 300 work units in the last week. 11 of those have failed, and that's a 3.67% error rate. And I can also select this job in the top table, and it will filter the bottom table to show me just those specific work units. So I can see those 11 work units that failed. I can see what error messages they had. On this page, we can also filter by the error code over here. And there are buttons below the error code slicer that allow you to filter on jobs with or without process time. You'll remember that we collected process time from the work unit timings function. And this gives you the ability to filter out likely syntax or compile errors. So if I don't want to see all those syntax errors, I could say I only want to see jobs where there was process time. And those are the only ones I want to look at. The next page we're going to look at is the cluster efficiency page. So the purpose of this page is to show you how many work units were active at a given date or time to give you an idea if there are times when a cluster is being over or underutilized. So we were able to show this information because we captured the start and end time of each work unit from the work unit timestamps function. In the bar chart, we can see how many work units were active each day. Active means it was in a non-complete state, like running or blocked or submitted. The thing about this chart is that we can actually drill down to the hour, and that will allow us to see how many work units were active at a given hour. So what I'm going to do is I'm going to select just one cluster group, and I'm going to go to a 1 day range instead of a week. And now this is still showing me 391 work units on the last 1 day. I can drill down, and now I'm looking at how many work units were running hour to hour. And work units are counted for each hour that they were active. So if a work unit ran from 2 to 4 a.m., it'll be counted at 2 o'clock, 3 o'clock, and 4 o'clock. So you can see here the times across the bottom. And if I want to see what was running at a specific time, so at 2 a.m., I want to see what work units were running at 2 a.m., I can select that. And now I can see all of the work units that were running at that time, whether they started at that time or started earlier and hadn't yet finished. And then this is really useful if I want to investigate what work units were active during a time when an issue occurred. So maybe you want to see what work units were impacted by a particular issue, or maybe there was some system issue and you're not sure what caused it, and you want to investigate what work units were running at that time that may have caused the issue. The final page we're going to look at is the DFU by job page. So this page allows you to see details about the DFU work units, and the information here was gathered from the SOAP calls that we looked at. And we were also able to tie together the job work units and the DFU work units by joining the DFU information collected from the SOAP calls and the DFU work unit IDs returned from the work unit timings function that we looked at in the beginning. So the top table is a list of all of the job work units that created at least one DFU work unit. And the bottom table shows all of the DFU work units and the information we collected about them. So if we want to see only the DFU work units that were created by a job work unit, we can select this DFUs with related work unit. Or if we only want to see the DFU work units that were not created by a job work unit, then we can select the orphan DFUs button. So you'll see this becomes empty because there are no job work units associated with these. The other thing we can do here is we can filter by selecting one of the jobs in the top table. We can see what DFU work units were associated with it. So if I select one of these here, now I can see that there were 2 DFU work units that were created by this job, and they were both D sprays. And then I can look at the statistics over here, see what the total size was and the total duration spent in those DFUs. And then the other thing on this page is there are some specific DFU filters. So the DFU type allows us to see if we only want to look at copies or we only want to look at sprays, we're able to filter by that. We can also filter by the destination group name, the DFU state, or the DFU specific owner. So that concludes the demo of the HPCC Thor monitor and our discussion on how to collect work unit information from Thor. I hope this was useful and it gives you some ideas for how you could collect this information and then use it to report on your system activity. Please let me know in the chat if you have any questions. Thank you.